Welcome to Bot Thoughts by Amtalk Soft. I'm Alex, and joining me as always is Sam. Sam, here's something I've been seeing everywhere. Developers either love the term vibe coding or they absolutely hate it. And I think both camps are missing something.
Yeah, the term is doing a lot of work right now. What Andrej Karpathy originally meant by vibe coding was essentially, describe what you want in natural language, accept the AI output without fully reading it, and iterate. It was almost tongue-in-cheek. He was describing how he personally builds small throwaway projects. But the industry grabbed the phrase, and now it means everything from GitHub Copilot autocomplete to fully autonomous AI engineering agents.
So what's the actual spectrum here? Because I've heard people use vibe coding to mean pressing tab in Copilot, but also to mean spinning up Claude Code and letting it write an entire feature while you watch.
Let me break it into 3 tiers. Tier 1 is AI-assisted, autocomplete, inline suggestions, ChatGPT for looking up syntax. The developer is still writing most of the code. Tier 2 is AI-augmented, tools like Cursor or Claude Code where you describe a task in natural language, and the AI writes the implementation, tests, and sometimes docs, but you review and direct it. Tier 3 is fully agentic. The AI autonomously plans, implements, runs tests, reads the output, fixes errors, and repeats, with minimal human intervention per cycle. Vibe coding properly refers to Tier 3, but most of what people call vibe coding today is Tier 2.
And what's the difference between Tier 2 and Tier 3 in practice? Because from the outside they look similar, you describe something, the AI does it.
The key difference is the feedback loop. In Tier 2, you're reviewing after each step. The AI writes code, you read it, you say continue or fix this. In Tier 3, the agent has access to tools. It can run a terminal, read test output, browse documentation, call APIs, and make decisions based on what it sees. It loops without waiting for you. Companies like Cognition with their Devin agent or the open-source SWE agent from Princeton, these are Tier 3 systems. They can take a GitHub issue and submit a pull request with a fix, 0 human keystrokes in between.
That sounds amazing. So why isn't everyone doing Tier 3 all the time?
3 reasons. First, accuracy. SWE-bench is the standard benchmark for coding agents. It tests them on real GitHub issues from open-source repos. The best agents today solve around 50 to 60% of tasks. That sounds decent until you realize the ones they get wrong can be expensive. They write plausible-looking code that breaks other things. Second, context. Long agentic runs accumulate context window usage fast. A 200K token context sounds huge until you're passing in 5 files, test output, error logs, and 3 iterations of fixes. Suddenly you're hitting limits. Third, trust. Autonomous code changes in production require guardrails most teams don't have yet. You need good test coverage, CI gates, and clear boundaries for what the agent is allowed to touch.
Okay, so the accuracy issue, 50 to 60% on SWE-bench. That means the agent fails on almost half the tasks. How do teams actually use agents productively given that?
Smart scoping. The teams doing agentic engineering well are not pointing agents at their entire codebase and saying fix everything. They're carving out well-defined, bounded tasks with clear success criteria. Write unit tests for this function. Refactor this module to match this interface. Implement this API endpoint given this open API spec. Tasks where the pass-fail signal is unambiguous. Does it compile? Do the tests pass? Does the linter pass? When success is measurable, agents work extremely well. It's the fuzzy creative tasks, design this architecture, make this feature feel better, where they still struggle.
Let's talk tools. If someone wants to move from Tier 2 to Tier 3 today, what are the actual options? I know Claude Code, Cursor, Devin. What else is out there?
The landscape is moving fast. Claude Code from Anthropic is probably the most capable right now for pure coding tasks. It runs in your terminal, has strong tool use, can read and write files, run commands, check Git status. Cursor Agent Mode is the IDE integrated option, great if you want to stay in your editor. Devin is the most autonomous, but it's cloud-hosted and expensive. SWE Agent is open source and runs locally. Then there's a whole tier of orchestration frameworks. LangGraph lets you build custom agents with stateful loops. OpenHands is an open-source platform specifically for software engineering agents. And Aider is a terminal-based coding agent that's been around longer than most and is surprisingly good. Each one has different strengths around context management, tool access, and how they handle multi-step tasks.
I want to push back on something. There's a criticism I've seen from senior engineers that vibe coding produces code that works now, but is unmaintainable 6 months later. Is that a real problem or senior engineer gatekeeping?
It's both, honestly. The criticism has real merit at the extremes. If you're purely vibing, accepting all output without reading it, no code review, no tests, you will accumulate technical debt faster than you can ship features eventually. I've seen production repos that were clearly generated wholesale with AI, and they're a nightmare to debug because nothing has consistent patterns. The naming is arbitrary, the abstractions leak. But the gatekeeping part is also real. A lot of senior engineers are just uncomfortable with AI-generated code on principle, not because of actual quality issues. The research from GitClear shows AI-generated code has higher rates of code churn, code that gets reverted or changed shortly after being written. But churn is one metric. Shipping speed is another. The question is whether the trade-off makes sense for your situation.
What should developers actually do to get good at agentic engineering rather than just vibing?
3 skills matter most. First, prompt engineering for code tasks, which is different from conversational prompting. You need to learn how to give agents precise context, what the code-base conventions are, what the function signature should look like, what the expected input and output is. Think of it as writing a specification, not a request. Second, test-driven agent loops. Write the tests first. Let the agent implement until they pass. This gives the agent a clear success signal and catches regressions automatically. Third, context engineering, knowing what to include and what to exclude from the agent's context window. Include too little and it makes wrong assumptions. Include too much and it loses the thread. The best agentic engineers are master curators of context.
Where does this go? In 2 or 3 years, what does software engineering look like if these tools keep improving at their current rate?
I think the job title stays, but the work profile shifts dramatically. The developer of 2027 is less someone who types code and more someone who reviews architectures, sets constraints, writes acceptance criteria, curates context, and manages a fleet of agents working in parallel on different parts of the codebase. It's closer to a tech lead or architect role than a traditional IC coding role. The skill floor for shipping software drops. You can build a working prototype with almost no coding experience. But the skills ceiling for building high-quality, maintainable, scalable systems goes up, because you need to understand enough to direct agents well, catch their mistakes, and design systems they can work within.
Key takeaways before we wrap. Vibe coding and agentic engineering are different things on a spectrum. Agents work best on bounded tasks with measurable success criteria. SWE-bench accuracy is around 50 to 60% for the best systems, meaning human oversight still matters. The skills to develop are specification writing, test-first loops, and context engineering. And the engineer role is shifting from writer to director. Sam, what should people go learn next?
Try Claude Code or Cursor agent mode on a real task this week, not a toy project, something in your actual code base. Set it a bounded goal, write a test it has to pass, and watch how it loops. You'll learn more about the current state of the technology in 1 hour of hands-on use than in 10 articles about it. Then look at SWE-bench leaderboard to understand where the benchmarks actually stand. And if you want to go deeper on the orchestration side, LangGraph's documentation on agentic patterns is excellent.
Love it. That's Spot Thoughts for this week. If this episode saved you from a bad decision or gave you something concrete to try, subscribe so you don't miss the next one. We're on YouTube, Spotify, and everywhere else you listen. And if you want to support what we're doing, buy us a coffee at buymecoffee.com/AmticSoft. Every coffee helps us keep the lights on and the models running. See you next episode.